download the procedure. So always start by reading the procedure. Okay, so we downloaded the procedure here. And then, yeah, you have the objectives of the lab. So make sure you keep track with the objectives. Are you achieving the objectives or not? So you'll be given values of velocity and acceleration, and you'll need to be able to describe the motion based upon the velocity and the acceleration value. So if I tell you, for example, an object going with speed, with velocity of 2 miles per hour to the right, and its acceleration is negative 0.5 mile per hour per second, describe the motion of this object. Describe the motion. And when you describe the motion, make sure to use certain terms like the object started, for example, from rest, it accelerated, it decelerated, it moved with a constant velocity. So make sure you use those scientific terms: accelerated, decelerated, it's moving at constant velocity, and so on. Okay. So that's the first purpose here. The second purpose, solve problems that involve position, time, and velocity. And I gave you several problems in the context of the lab. For example, this man started from position from the tree, position of the tree, and he moved to the wall, and it took him certain seconds, certain number of seconds. What was his speed, and so on. Number 3 here, given value of velocity and acceleration, describe the graph. Okay, so it's very important to be able to describe the graph. And again, remember guys, a straight line means constant velocity. Whether it's a positive slope or negative slope, it's a constant velocity, meaning the acceleration will be 0. If you have a parabola, a curve concaved up, this is acceleration. If you have a curve concave down, then this is deceleration, meaning the velocity is decreasing. And in addition to that, actually, also giving only the graph of position versus time of several accelerated objects, sort which one has the biggest acceleration. Let me give you an example here. If, for example, and this is the last question actually in the lab. Let's say I gave you here a graph of position versus time, and you had three parabolas, 3 curves concaved up in the same graph paper here. So this is the first one. This is number 1. And then let me draw number 2 with a different color here. So number 2 is very much lined up with number 1, something like that. They kind of overlap here. So you have number 2 as well here. And then you have graph number 3, and let me use a different color here. I'll go with brown. So you have graph number 3. Now all of those graphs represent a parabola. So all of them represent what? All of them represent acceleration. We know number 1 is accelerated object, number 2 is also an accelerated object, and the same thing for number 3. Now the question is which one, which 2, for example, have the same acceleration, and which, for example, one could have biggest acceleration, which one has the lowest acceleration. We can tell that also from the graph. So the graph will not only tell us whether there is acceleration or not, it actually will tell us which one has the biggest acceleration, if all of them have acceleration. For example, number 1 and 2 have the same steepness, So you can tell that number 1 and 2 have the same acceleration, because the slope is increasing at the same rate. Remember, the slope here represents what? The slope represents velocity, because the slope is the change in the position here, change in y over change in x, which is change in position over the change in time, change in position over change in time. And this is the definition of velocity. So slope is velocity. So here the velocity is increasing, and you can see the velocity is increasing at the same rate for number 1 and 2. While number 3 has the biggest rate of change. The slope is increasing at faster rate. So the velocity is increasing at faster rate, hence the acceleration is biggest for number 3 here. So the acceleration of number 3 is bigger than 1 and 2. 1 and 2 are equal. graph 1 and graph 2 represent the same acceleration. Okay, so that's another thing also we can conclude from the graph of position versus time. We can tell whether there is acceleration or not, and we can tell how big the acceleration is. Okay, so that's actually number 4, the goal of number 4 here. Now going down here. Yeah, here, number 3 here on step number 3 here is the link actually. This is where the lab will take place. Number 1 and number 2 is introduction videos that will help you. But number 3 here, this is the link that you need to download. And I have another link for you in case you were not able to activate Java on your computer. So you can use this link here, okay, this link here, or this one here. This link here, the middle link here, is a video that I showed you how to activate Java on your computer. There's no alternative link. Here, the good thing about this simulation, it has alternative link. This is open source link, actually. I don't know how long this source will be available. So far, it's available, so this is good. But I don't know how long will it be available. But yeah, if you have difficulty, watch this video on how to activate Java in case. Okay. Now, the lab itself is 2-part. Part 2 here is basically starting with the lab. In the first table here, after you download the simulation, you need to set the position, set the initial velocity, set the acceleration, and predict. Make sure to predict, just develop a hypothesis how the motion will be. And then you'll test your prediction by playing the simulation. As soon as you play the simulation, you'll be able to tell whether your prediction was right or wrong. Okay, so always, guys, start with prediction. This will test your understanding. You'll be able to test your understanding. Do that for all of them. And then after that, you can test it by actually doing the lab. Okay. And here I'm giving you the question in the lab quiz. So you'll have the same question here in the lab quiz about that. So this is the first table. The first table is about describing the motion, okay? The second table, which is part 3 here, you need to describe the graph you'll get. Meaning, are you going to get straight line? And if you get straight line, is the straight line going to be positive slope or negative slope? And also whether you are going to get parabola or a curve concave down. So here, yeah, this is table 3. You'll be describing the graph you'll get. So it's the same questions or similar questions, but it's about the graph you'll get. Okay. And then after each table, you'll have several questions to answer. So this is basically the simulation that you'll get when you click on the link, the download the simulation. And this is basically the value you're going to alter. For example, if you're asked to set the position at -9, you'll set at -9. Okay, so you see the man here now is placed at -9 meter. This is the 0. This is the reference point. Okay, this is the 0. So here he's set at -9. And let's say, for example, you're asked to set the velocity at 3 meter per second. 3 meter per second. Let's say positive 3 meter per second, meaning he's moving to the right. Okay, and you can show the vector if you want. When you set positive, you can see the vector is to the right. If I set it negative, okay, if I change it to -3, you can see now the vector is to the left. So positive and negative is just directions. Okay, so let me just keep it positive here, +3. And let's say the acceleration, I'm going to set the acceleration at -0.5 meter per second square. And let's look at the direction here. So I'm going to check the box here, show vector. And this will show you the vector of the acceleration. So you can see here the green vector here is the vector is the acceleration vector. It's to the left because I set it negative. Now, what do you expect here? Is the man going to move with a constant velocity? Is he going to accelerate or decelerate? So this is the thing you need to talk about when you describe motion. So you'll predict and then you click play here. You see the play here. So it will show you the motion of that man. Okay, and you can see now here he's slowing down, okay? So he's decelerating, okay? Until he comes to a stop. And that's what we expect. Now, how about the chart? Now, if we, in the second part, or actually the third part, you look at the chart, and you'll focus only on the position versus time. You don't need to worry about velocity versus time and acceleration versus time. We'll focus on position versus time. Okay, and the same thing, you'll set the position, and you can set the acceleration value and the speed value and do the same thing. So you set let's say you set the position at -9 here. You'll set the velocity at, like before, we set it, let's say at 5 meters per second, positive. And we set the acceleration at, let's say negative 0.5, negative 0.5, so 1/2 meter per second square. And what do you expect? What type of graph do you expect to get here? Of course, the graph would depend whether the object is accelerating, decelerating, or moving with a constant velocity. Since here we have deceleration, so we predict that we'll get a curve concave down, right? So let's see if that's what we are going to get. So I'll click play. You can see here the motion. Let me clear here, start. And now you can see here it's plotting the graph while the man is moving. And